Okay, we're going to be discussing section 2.1 today, which deals mostly with the slope of a limit. And basically, the slope of the limit or the line looks like this. 2 points, and we're trying to find the distance they are from each other. And to find the distance of the secant line, you're first going to use the formula m equals limit f of x as h approaches 0. And you're going to have f of x2 minus f of x1 all over x2 minus x1. We use this formula to determine what the slope is, which is, if we look up here, x2 and f of x2, and then that's the furthest away, and this side is going to be x of 1 and f of x1, and that's the one from furthest away from the left. So this is going to be a slope over average rate of change. Example of this would be if we had x squared minus 4x, and we were plugging in the values of, or plus 4, sorry about that, and we're plugging the values of 4, 7, and this, the first point would be x1, and the second point would be x2. What we're going to do now, we're just going to plug in the numbers for the bottom one. So you have x2, which is the 7, and x1, which is the 4. And to find the top part, we plug in x2 for this and see what we get. So we have 7 squared plus 4 times 7, and that's gonna give us 49 plus 28, which is gonna give us 77. In the second part, we do the same thing. 4 squared plus 4 times 4 is gonna give us 16 plus 16, which is going to give us 32. So now we know what the difference is on top. F2 is going to be 77 minus 32, which is going to give us 45 over 3, or just 15. So now we know the equation for secant line. Let's find one for the tangent line. Tangent line, as we know, is a line that looks like this. And we know that it's going to touch one point and won't touch at all again. So we're finding out what, if the graph was to look at this the same, how long would it take, or what would it take for it to reach 0? So the equation for this would be f x1 over minus h minus f of x1 over h, and that's the limit for tangent. Now we know h already because h is equivalent to x2 minus x1. So we already know what h is. Example of this. So whatever number, if we have a equation like this, y cubed minus 2x squared plus 4, and you have the point of 3 and 13. Now realize this is the point where it takes for it to reach 0, or the point where it takes for it to intersect. So we are going to plug in, because we already know what 1 is. x1 is 3. So it's going to be f3 minus h minus f of x1 over h, or f of x. Now, to find out what this is, or how this equation right here, we're going to plug in a 3 for this. So we're going to have 3 squared minus 3 squared. 3 cubed minus 3 squared plus 4. And you're going to have 9 minus 2 times 3 cubed, 3 squared is 9 times that is 18 plus 4. And you are going to get a number of 13, which is exactly what we want. And you're going to see why we want to have the 13 right here. So as a matter of fact, we don't need this anymore. We could just write the number 13 right here. So now that we have this formula, we're going to plug this in for this right here. So we're going to have 3 minus h cubed minus 2 and 3 minus h squared, all minus 13. And that's going to give us 27 plus 9h squared plus 27h plus h3 minus 18 minus 12h minus 2h squared plus 4. And this is going to be all over h. So we go back, plug that in. We know we have some common factors, so we're going to cancel some of them out. And let's not forget, we still have the 13 at the end. So the limit as h approaches 0 would be h cubed plus 7 squared plus 15h plus 13 minus 13. Now we see automatically that we could cross 13 now, and remember this is all over h, and we could pull the h out, and this now turns to h squared, 7h, and 15, and we get rid of the h's. Now you're left with limit h approaching 0 as h squared plus 7h plus 15. We're going to plug in 0 for the h's, and we're going to get 0 squared plus 7 times 0 plus 15, which is going to give us 15. And that's how you solve it for that portion.